Hello, everyone. We'll be starting with the session now. Hello, everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 60. Myself, Anshika Jain, and this session would be moderated by me. On the behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 9th International Congress on Information and Communication Technology, ICICT 2024, London, UK. The 9th edition of this conference is being organized in a hybrid mode. The physical event was organized in London, UK on 19th and 20th on 90th and 20th of February 2022, and the virtual event is being held through Zoom today and yesterday, that is 21st and 22nd of February 2024. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. Coming to the guidelines, in this session, we have 6 presentations, and each presenter will be given 12 minutes for the presentation and 2 minutes for the questions and answers. On 10 minutes, I will raise a very gentle reminder. There is another request to all the participants to kindly stay connected with us till the closing remarks. If you have any queries or any updates, you can write it to me in the chat box below. Just before we get started, I would like to introduce you all to the session chairs for the session. First up, we have Dr. Kalpesh M. Popit. Sir is currently working as an assistant professor in the Department of Mathematics at Surakshatra University, Rajkot, Gujarat, India. He has over 12 years of teaching experience in worldwide journals with Scopus and SCI indexes. He has 12 research papers published in both national and international conferences. He has delivered 11 papers. His areas of interest include graph theory, business and mathematical statistics, R programming, discrete mathematics, and more. Welcome to the session, sir. Would you like to share a quick opening remarks with us?
Yeah, thank you, madam. Good morning, good evening, good afternoon to all of you joining us from around the world. It's my great honor and privilege to welcome you all in this technical session of this prestigious international conference. As we gathered here, we are presented with a unique opportunity to engage in a meaningful discussion, share valuable insight, and foster collaboration in the field of information and communication technology. My best wishes to all the participants for their good presentation. Thank you very much.
Thank you so much, sir. I would also like to introduce our next session chair, Dr. Chak-Chai Soen. He's a professor of computer science with the Department of Computer Science in Khon Kaen University, Thailand. He has interned with Cisco Networking Academy, Cisco Systems, WiMAX Forums, and Bell Labs. His research interests include computer networking and internet, wireless and mobile networking, the Internet of Things, wireless sensor networks, signal processing, cybersecurity, and applied intelligence systems. Welcome to the session, sir. Would you like to share a quick opening remark with us?
Okay, thank you, Anshika Chen, right? Okay, I think welcomes all of you to these sessions, the International Conference on Information and Communication Technology, and I think all of you have the good, research to share, right? And hopefully, we can have maybe future collaboration with each other. Please come and learn, and then we can get some good comments, and possibly we can just extend that to the journal. And looking for all of you to the next year ICT as well. Thank you.
Thank you so much, sir. So we will be moving on with the presentations now. So first up, we have Lorna to present her paper titled A Mobile Location-Based Recommender, Guide and Monitoring Application for Bikers Using a Search Algorithm. Are you there, ma'am?
Hi. Good day to everyone. Can you hear me? Am I audible?
Yes, ma'am. We can hear you. You may start with the presentation now.
Okay. So once again, good day everyone. I'm Lorna Lim from the Technological Institute of the Philippines. And together with me, this research paper are my colleagues who's also here in the Zoom presentation, Miss Jasmine, Miss Janice, Miss Kay, and Miss Karen. We would like to express our deepest gratitude for giving us a chance to present our paper. Please allow me to share my presentation.
Yes, ma'am. I've allowed you to share the presentation. You can.
Share screen. I'm Lorna Lim from the Technological Institute of the Philippines, and I would like to present to you our research entitled A Mobile Location-Based Recommender Guide, Location Application for Bikers Using A-Star Search. A survey with the World Bank Group and the national government agencies revealed a surge in cycling among Filipinos during the COVID-19 lockdown. Within 9 months, the Philippines created nearly 500 kilometers of bike lanes, promoting cycling as the sustainable transport. With this, the researchers developed mobile application for bikers, offering navigation, reminders, weather forecasts, activity tracking, bike maintenance advice, and cycling suggestions, focusing on efficiency and resourcefulness. The mobile application user interface functional are illustrated here in the diagram. Once the user registers, their information is stored in a database, and they can use the app to navigate locations, track activities, record bike parts, and view all possible routes or paths using the A-star search algorithm that would determine the best or the optimal thing. On our mobile app, this is the onboarding screen. As soon as the application is launched, this screen will be displayed. This will show the introduction of the application to the user. The next button will show the other information, though they may also click the skip button that will proceed them to the non-login navigation screen. Next, we have the home navigation module section. This allows the user to grant permission access to their device's location using the activity compact check self-permission. The Google Map fragment has 7 image buttons to change map, zoom in, zoom out, reset map, and show the route. Next is the searching nearby place type module. This will allow the user to select his preferred place using the Google Nearby Search API. It will enable to get to the nearby place on what the user has selected. Next, we have the drag and drop marker module. It shows that this will allow the user to drag and drop the marker to a specific location to navigate its route. Next, we have the global location navigation search module, which allows the user to search the desired place and navigate itself. Next, we have the cycling tips module. This would offer the cycling tips, including the do and don'ts. Next, we have the activity summary module. This will display the destination address, the distance, speed, average speed, and expected calories burned. The data is retrieved with JSON response and displayed on text view field, speed calculation involves the distance converting to miles and times in hours. The average speed is calculated by total distance divided by time. Expected calories burned is calculated based on the user's body weight. Next, we have the activity plan module. Here we have two activities, the weather activity and the calendar activity. User can edit and delete recorded activities, and the application also allows the user to set alarms for scheduled activities. Next, we have the bike maintenance and repair module. Here we have the recommender module. The module allows the user to select the area type, the road type, province, city, using autocomplete text view, and the array adapter. It would recommend the location based on the user's selected area, type and display related addresses on the card view with horizontal layout. The module also provides a clipboard service for copying addresses and displaying them on the phone or a navigation module. Again, for the mobile application modules, we use the A-star search algorithm to calculate the direction using the Google Map Directions API. The data is parsed and modified to produce estimated distance, duration, speed, and average speed. The algorithm determines the best route for the user's current location to their destination addresses. The study applied the A** search algorithm to find the shortest path from the start node to the target node, considering the traffic rules from the Google Map Direction API. The algorithm prioritized the smallest distance from the starting node and uses the heuristic approach to estimate the distance from starting node to the destination node. For the summary of findings, an evaluation was conducted for both technical and non-technical users as respondents in accordance with ISO 9126. The Likert scale, which ranges from 1 to 6 and start with strongly agree up to strongly disagree, can be used to respond to the questions based on the result of the evaluation. Functionality has a mean of 5.14. Reliability has a mean of 5.23. Efficiency has a mean of 5.24. Maintainability mean is 5.02. Portability got 5.11. All were sorted to and agree as the interpretation. The following states the conclusion of the research study. Develop a mobile application with a guide and monitoring system for bicyclists. The study was able to use a search algorithm which enabled path finding for the biker's desired destination. The researchers also created an application that would help the bikers have a better picture of their activities and future activities. And this mobile application is able to satisfy ISO 9126 while enhancing the biking experience. Recommendation for the future researchers. Number 1, bike sharing module, where the system would consider not only the user, but also the possibility of renting or returning a bike at a given station for potential future bike users. Next is the bike parking location module, where the system would identify optimal location for bicycle parking. Next, we have recommended additional neural network features. This will enhance the A* search algorithm for personalized route recommendation. Thank you for listening. The researchers for this study are Ms. Jasmine Kaliwag, Ms. Janice Capule, I myself, Lorna Carpio Lim, Ms. Karen Delara, Dr. Karen Joyce Ison, and Mr. Kenneth John Estrada. Once again, thank you, everyone.
Thank you
Good
so
day,
thank you so
everyone.
thank you so much for your presentation, ma'am. Sir, do you have any questions?
Yes. So my first and fundamental question is how this application is different from other applications that is in similar area.
Hello.
Yes, ma'am.
Yes, there are already existing, almost the same, but according to what we have researched, this is quite better because of the chosen algorithm that we have implemented, which is the A-star search algorithm.
Okay. Thank you.
Will that be all? Thank you,
Okay,
sir.
a few questions from me. I think it's a good
Hi, sir.
application that you can use in your
Thank you.
faculty or university, right? So, but maybe two quick questions. Just first thing is, I mean, normally, I mean, I think you use the distance, right, to identify if it's a good, I mean, route or maybe the shortest route, right? So
Yeah.
you use the distance, right? But in fact, in the real street or real road, I mean, some junction, there is some junction or traffic light. So the distance may not only the only one factor to identify the optimal route, right? So how to deal with that?
Actually, it was also considered, but not that intense on the topic. Some tests uh, were conducted that those parameters were also considered.
So maybe
Not
in the
just
future you
the
can just modify
time
the
and
searching
distance.
algorithm.
Yeah,
So to take care
we
of the
considered
multiple
not just the
parameter, right?
distance, but also the time.
Yeah, I mean,
We will,
unless it
sir.
can make a better, I mean,
Thank you for that
optimal
recommendation.
solution,
Yes,
right?
sir. We will po.
Okay, okay, that's all for me. Thank you.
Thank you so much, ma'am, for your presentation. So we'll be moving on to the next presentation. Next up, we have Miftachul.
Okay, sir. We will, sir. Thank
Yep.
you for that recommendation.
Next up, we have Miftachul
Thank you.
to present his paper titled ChatGPT in Supporting Education Instruction Sector, an Empirical Literature Review. Are you there, sir?
Yes, I am here.
Okay, sir. You may
Yes.
start with the presentation, sir.
Yes. Okay. All right. Thank you so much for the. Okay, let me show the my slide first. Yes. All right. Anyone can see?
Yes, sir. Your screen is visible. You may start now.
Yes. First of all, I would like to thank you for the Mr. Ceremony for allowing us to present our chapter ChatGPT in Supporting Education Instruction Sector and Empirical Literature Review. Very good afternoon from Malaysian time, and on behalf of our authorship, including Azlini Anwatan, me, Miftachul Huda, Muhammad Abdul Rahim, Tuan Rosmawati Raja Hassan, Azman Ismail, and Mara Gustam Siregar. Now, ChatGPT as the outstanding artificial intelligence software and technology has expanded with the potential to provide several benefits. For example, educational institution, including the increasing engagement, collaboration, of course, and also student accessibility of the learning resources, ChatGPT has been the significant tool to help improving, especially for the learning resources. And the further innovations emerge in the development of education, like, for example, strengthening students' writing abilities in schools or universities as a new learning approach. However, not many studies are trying to elaborate more on looking into detail about the supporting, whether supporting or disturbing. Now we are focusing on how ChatGPT, with its feature characteristics, how it help improve the learning resources support. And from that, our objective of the study is in order to maximize the benefits of adopting ChatGPT while addressing existing constraints, it is imperative to carry out ongoing research and development. And from that, ChatGPT technology might support and enhance the learning process, whether it is both individually and collectively. And this paper, this study, aims to examine how ChatGPT, mainly in education sector, how it supports or disturbing pathway. Since our approach of this paper is literature review, which is also known as the research process that involves review, analysis, and synthesis of relevant and pre-existing sources of written information. The sources of information can be in the form of scientific articles, like, for example, books, journals, this reports, and also other resources that have been previously published. And in this paper, the author tries to describe and conclude against the use of ChatGPT in education. As the four source of articles and scientific journals published on the internet through the utilization of ChatGPT technology in the teaching and learning process. Now, the finding revealed that this ChatGPT, with its feature concept, would like to give beneficial potentials to be a valuable tool both in the classrooms and in the self-study situations. Meaning that how the supporting system that provided by ChatGPT can be accessed during the classroom process and also outside of the classroom. In more detail, ChatGPT can provide activities and interactive quizzes to measure students' understanding and provide immediate feedback. And from this scenario, it is followed by the extent of language support, as the technique can help students improve their communication skills. And thus, from this arrangement, it would enable to practice speaking, for example, and writing in the target language.
Sorry to interrupt you, sir, but are you moving your PowerPoint presentation? Are you changing pages?
Yes, yes. Oh, sorry. I'm sorry. Oh,
Because you were not like changing the.
sorry. Oh, I thought my slide is working, but unfortunately, oh, sorry. I have from the first until the okay.
It's okay,
So
sir. You can continue from here.
okay. Sorry, yeah. Okay, very sorry. Now we are going to implications and future directions. In terms of encouraging the exploration, the use of ChatGPT to provide individual study aids, for example, and even assist among the students in exploring areas that are interesting, can increase their enthusiasm, yeah, can increase their enthusiasm for self-study. And from this scenario, ChatGPT is more adaptable to adults and can be used in a number of circumstances. For example, even for study or work aid, there should be, for the future direction, there should be appropriate monitoring and control methods in educational environments or applications, which is to guide the children to ensure the safety and privacy of underage users. And for the conclusion, several ways to help ChatGPT in the learning process. Throughout, ChatGPT might provide students with customized study aids, which is this might provide the way of answering for the questions and even for explaining certain subjects of the discussions, and also providing guidance in the natural language, which is simple and give the way easy to understand. As a result, the access to learning resources, this how the ChatGPT supported instruction might give students easy access to reference materials and also additional learning resources, in the sense that it would be the pathway to enable these learners to understand course material better compared to the old way of reading independently, which can be easy to understand and also can also be misunderstood or not clearly achieve the message. And that's for our presentation today. Any questions, comments, feedback, and also any discussions, very welcome. Thank you very much.
Thank you so much for the presentation, sir. So do you have any questions?
Yes, I would like to ask one question that, yeah, it's fine that ChatGPT is helping the student as well as teacher in learning. But in many cases, we have find that students are using ChatGPT for their homework and assignments. So is there any way to identify that the content was AI based, or is there any tool that as a teacher we can identify that this content is AI based? Because in many cases we have seen that when students are writing research paper using ChatGPT. So if you
Yes,
can.
thank you. Yes, thank you, Dr. Kalpest. All right. I think as the teacher and educator, we should ensure that our students might have the individual capacity of we call as controlling applications, individual based controlling application intelligence, meaning that ChatGPT as the tool to help working their assignment, while we should ensure that what has been found from the ChatGPT should be connected or should be linked with the material resources, which is the, like for example, we have books, whether it is similar or against.
But
And
because many websites, many AI-based websites, I have seen that they
yeah,
give content which is you cannot plagiarize this content. There are
yes,
many websites which gives the content, they change the sentences, grammatical something, and then if you try to find that whether it is a plagiarized content or not, you cannot catch them. So the problem is I have not find any tool that gives me that this content is AI based and the student has mischief something.
Yes, I think the most important thing is how sometimes ChatGPT, the way of language presented, the way of language present from ChatGPT, sometimes we can see, oh, this is like AI tool, for example. So from this, I think as the for example, examiner, we can see from the scanning process, we screening process. The second one might be we can make scanning, and also we can make the instruction first. That only might be certain percents allowed from the ChatGPT sources. So meaning that we can make the students self learning. At the same time, we can manage ChatGPT properly in line with the proper manner, which is not totally depend on ChatGPT. Yes, I think yes, Prof. Yes, thank you. Anyone else for the questions, comments, or feedback?
So, do you have any questions?
Maybe just my suggestion then. I think you can improve this kind of research to basically include the recent works. I mean, who use this in what way, and then we can just make the comparison table to
Yes,
see
Prof.
which one is it watch, and then the challenge, if you can want to place it, like the doctor Popat say that is challenging because we don't even know. I mean, if the student use the AI based, right? That is challenge, and then maybe somebody already did some research, like I think once some team in from Princeton, they do the ChatGPT. I mean that kind of information is good, and we can learn from them, right? I think we can extend this kind of the proceeding to the good journal if you can put those knowledge. Anything existing in this world, and then hopefully you can pose some challenge in the next few years. So, for example, what should be the next Chat GPT? Can it be? Can it replace our tutor or instructor like that, right? And that is what we want to know. And I think you can keep doing this, and then you can hopefully you can bring some maybe idea, right,
Yes,
to
Prof.
the Chat GPT. Okay, thank you.
Yes, Prof. Yes, thank you, Prof. Thank you very much for feedback. And yes, we will further study for the extents like Prof said just now. Yes, Prof. Thank you, Prof.
Thank you so much for your presentation, sir. We'll be moving on to the next presentation. Next up, we have Muhammad to present his paper titled Developing Personalized Islamic Learning in Digital Age, Pedagogical and Technological Integration for Open Learning Resources. Are you there, sir? Are you there, sir? Okay. So next up, we have Miftachil to present his paper titled From Technological Adaptation to Technological Adoption, an Insight into Public Islamic School Administrative Management. Are you there, sir?
Yes, yes, I'm here.
Okay, sir, you may start with your presentation.
Okay, thank you. All
Yes,
right,
sir.
thank you very much for allowing us to present the next paper titled From Technology Adaptation to Technology Adoption, and insights into public Islamic school administrative management. All right. Our introduction is that the current trends of technology advancement offered with such features have given a substantive support to the human development, including social life interaction, business, and also education sector. It is especially in the government sector that technology development is currently being the trending topic, since the gradual shift paradigms comes to adapt such distinctive structures in order to reach the beneficial value contained from such advanced technology progression. And thus, our focus of this paper is to investigate the technology adaptation followed by its adoption in giving a critical insights to help to run the administrative management of public school. And since our paper based on literature review, the analysis was made by reviewing the current works related to the technology adaptation and its adoption. And from this arranged basis, it would contribute to the public school administrative management as supposed to enhance the way how administrative management can be delivered smoothly in line with the objective, in line with the targeted plan. And our results or our finding is that the finding of the study found that the significant features of advanced technology enhancement might provide a sustainable contribution in playing the role on helping to systemize the administration procedure and processes. In the sense that it would be in a good flow and proper way, in line with the original objective, in line with the target plan of the organization. Regarding the contribution of the paper, this study is supposed to contribute in giving the particular insights, mainly in developing the framework to look into detail about the clearly point the way how technology adaptation and adoption could be managed properly to contribute to help work production amidst the public school administrative management. Meaning that how the technology adaptation from the adoption to adaptation, it would give the beneficial value, which is to deliver the information from the administrator, from the officer to the educator or to the education actor, which is students and or learners, and also among the teachers. And our conclusion is that this paper, since this paper aims to investigate the technology adaptation followed by the way of adopting the critical insights to help to manage the administrative management of the public school, this paper is supposed to contribute in giving the particular insights on developing the framework and looking at the clear point about the technology adaptation and adoption on administrative management. And that is our today's presentation. Any questions, comments, feedback are very welcome. Thank you. And, yes.
Thank you so much for your presentation, sir. Sir, any questions?
Yes, madam. First of all, I don't find anything which we call it as a research, because if you have done any analysis work, then you might represent the charts analysis or some hypothesis test. But so far in this presentation, I don't find which either you can write the conclusive statement, what conclusion you have made by doing this analysis. So I don't think so I need to comment something. Thank you.
Yes, thank you, Prof, for the feedback. Yes, of course, uh, complete, we will revise according to comments, and of course, to improve the paper to be more uh, uh, understandable and also within the scientific template and scientific yes.
To me, so actually, as I message, I think it's good to have the question from the audience, right? If any has the question, please say out loud, or even just write the chat, right? But anyway, yes, I'm not sure, right? But just my personal suggestion, but uh, you may just ignore it, right? But I think based on the two paper that you presented, I think it's worth if you may look at the social science conference, right? It is the best. It's from the educational world, and I think that society may uh, see some insight which impact to the real world, right? But why I believe why Dr. Topas said that, because in the technical, world, we want to see some graph, some experimental analysis, even the some theory or something, right? So, but in the social side, they may not have, but they do some the real, not experiment, real, say review or something, and do some analysis based on those. I think that venue may, I think you can get some good recommendation. I think, and I think you can just, try, right? And I
Yes,
think
Prof.
that can maybe is your answer.
Yes,
Okay,
Prof.
but I don't say that you shouldn't submit here. But what I say is, in different venue, they may, I mean, see some insight, as I say. But from my perspective, it's difficult for me to see the inside of the paper, right? But it's good because in fact, I also in different venue, like in the humans and society, in the social science journals, they also try to uh, get some. It's not, it's like some not experiment, but some reviews, and
Yes,
then
Prof.
you can analysis from those reviews to get
Yes.
the actual answer, right? It may not be right or wrong, but that is the true value of the societies. Okay, this is just my comment. Thank you.
Yes, Prof. Thank you, thank you very much, Prof, for very helping comments. Yes, of course, we will improve our paper. Yes, Prof.
Thank you so much, sir, for your presentation. We'll be moving on to the next presentation with this. So next up, we have Hannah to present a paper on synthetic data for feature selection. Are you there, ma'am? Are you there, ma'am?
Yes,
Good.
yes.
You are
Can
there,
you
ma'am?
hear me?
Yeah, ma'am.
Yeah. Okay. Okay, just allow me to share.
Yes, ma'am. You may start with your presentation.
Sure. Thank you. So can you see my screen?
Yes, ma'am, we can see your screen. You may start.
All right. Well, thank you everybody for being in this session and listening to my talk. My name is Hannah Suleiman, and I am presenting this work on behalf of my co-authors, Dr. Fayrouz Al-Rohan, who is a master student. We are from the United Arab Emirates. Dr. Fayrouz is from the Canadian University in Dubai, and I do work in American University of Sharjah. And our work concerns synthetic data for feature selection. This is going to be a little different from the presentation so far. There could be, it's more into the math and stat content. So our goal in this work was to investigate the performance of popular feature selection algorithms in the context of imbalance classification problems using synthetically generated data. In this paper, we have looked at, or we examined 8 different feature selection algorithms using 8 different synthetically generated data sets. And also we implemented different imbalance ratio in the analysis. So as an introduction to the topic, you all very well know that, the reliability, the accuracy of machine learning models really depends on the quality of the inputs or the features. So with that, in that perspective, feature selection process becomes an essential step for identifying the relevant features in a data set. Just a simple naive example, for the height of a patient may not be useful for cancer diagnosis, but age might be. So here the age as a feature is more relevant to the output than the height. The selection of the correct relevant features can have significant impact on the effectiveness of the downstream task in machine learning and data science pipelines. Given that, and remember also, in feature selection, we aim to reduce the dimensionality of the data that is usually big one and lack the ability to manage the data. Given it's important, there exist several dozens of feature selection algorithms classified into 3 main frameworks. So the literature on feature selection really classified them into 3 main classes. First one is called wrappers, and in this wrappers, what we do, we select a subset of features, and then we train the model on the selected subset, and we check the prediction accuracy, and then we go back and select another feature subset. So if I have K features, then the total number of feature subset will be 2 to the power K, which is a huge amount for when K is too big. However, in filters method, filters are considered a pre-processing approach where we evaluate the importance of these features before we inject them into the training and into the machine learning model. Embedded method, it's in between, where now the embedded methods, what they do, they consider the feature selection process as part of the training of the model. Okay, so this work focuses on a classification for imbalanced data. Imbalanced data meaning when I would have minority class and I have majority class. I'm talking here about binary classification. And feature selection algorithms, they suffer from severe bias against the minority class. So when you do prediction, and if you have heavy imbalance, then the prediction will tend to favor the majority class always. Imbalance reduction techniques, there are, of course, number of techniques that reduce that imbalance using oversampling, undersampling, cost-sensitive learning techniques, where in cost-sensitive learning techniques, it treats different misclassification cost differently. So that is also, this is one of the learning techniques that used to handle imbalanced data. Real data sets are used to evaluate feature selection algorithms in imbalanced data. Two main problems with that. First, when real data, you rely on the accuracy of the classifier used, okay? So if you use neural network, for example, as a classifier, then the neural network may favor one of those irrelevant features in the data. So it really depends on the accuracy of the classifier implemented there. Traditional evaluation metrics are not suitable for imbalanced data because of the bias that I spoke about earlier. So to address the above problem, what we are proposing in this work is to generate synthetic data sets, and we use those synthetic data sets to evaluate feature selection performance for imbalanced data. So synthetic data, why they are favored, or what are the advantages over real data? At least that's what we see it. Well, for synthetic data, because you generate them, you make them up, you have a full knowledge of the features, the relevant, the irrelevant, the redundant, and the target variable as well. There is a control of the parameters to explore different scenarios. You really can tweak these different parameters to create different scenarios. Eliminates dependency on the choice of the specific classifier and measure of the accuracy. Well, now you don't go for F1 score and accuracy measure, those traditional accuracy measures. Since you know the relevant feature, then one accuracy measure would be the number of relevant features selected. Allows control of noise in the data set and degrees of freedom. Also, you can really control the number of instances you want to inject in the data set. The proposed data sets are based on application from various real-life applications. They are inspired by different applications, and we make those available. Those data sets were created in Python. They are available for free on GitHub at this link. Here, I'm just going to give you a glimpse of those. In this recent paper that we just published, we have created 10 data sets, again, inspired by different applications. And so here I'm just presenting 3 of them. For example, for the trigonometric data set, what we have done, we have 2 main features or relevant features, F1 and F2. And we created those generating from a normal distribution. And then we injected this boundary decision curve by the sinusoidal decision boundary curve by the sine function. So now we have the true and false. By this inequality, we can determine a binary output being false or true. Another technique or another data set where we have 3 relevant features forming this hypersphere equation, and then with that inequality showing there 900 greater than x1 squared, actually it is f1 squared plus f2 squared plus f3 squared, and if that inequality fulfilled, that will be a true, otherwise it's going to be false. A yin-yang data set here, it's inspired from the Chinese philosophical art, and in this one here we have taken converted the image to pixels, and the coordinate of the pixels become our relevant features, and the color is the target variable in here. So this is just again a sample of the data sets that we have created among the 10. So we have used 8 of those 8 give us binary target variable for this work. And so we have the relevant features, as you can see, they vary from 2 to 5. We injected redundant, we added to the data set redundant, and those redundant, we create them as transformation of the relevant features. And also we injected irrelevant features, we generate them from irrelevant distribution, if you wish. And here the total is the total number of features. So we made all of them like 200 or 400 and so on. So those are the data sets that we have used. Now, for the feature selection algorithm that we have used, we used 8 popular FSAs, the feature selection algorithms. Some of them fall under the filter method, like entropy, chi-square, mutual information, symmetrical uncertainty, MR. Those are under filter techniques. However, sequential backward selection, sequential selection in general, they fall under wrapper technique. Genetic algorithm is a new breed of search algorithms that are inspired by the natural selection and genetics. In testing these, we control the imbalance.
Sorry to interrupt you, ma'am, but you have 2 minutes to conclude your presentation.
Yeah, sure. Thank you. So we vary the imbalance ratio here, and we use the precision as relevant selected over total, and we requested to the feature subset to be number of relevant or twice the number of relevant. Here are the results from these 8 techniques or 8 feature selections, and this is the percent. On the y-axis you can see the precision. The precision here, the top 3 feature curves represent the sequential selection, backward and forward, and entropy, that are insignificantly different. This is for number of features, relevant features. The same graph we see for twice number of relevant features. We took that curve and we looked at the variability and so on, and we compared these box plots and we conducted the statistical test on them. And finally, we realized that the sequential feature selection algorithm seems to have high precision and low value of R and has lowest variability compared to entropy and SPS. We also looked at the execution time, and among these we discovered that entropy is the second fastest algorithm and enjoy acceptable stability as well, and so on. But the sequential approach, as expected, they are wrapper techniques and they require definitely more execution or time to compile. These are the algorithms, and this is the code for the GitHub link. And I think I'll stop here. And thank you for listening. And this is a nice picture of our campus. Thank you. I'm willing to take any question you might have.
Thank you so much, ma'am, for your presentation. So do you have any questions?
First of all, I would like to congratulate the participant for such a wonderful presentation.
Thank you.
I don't have any question, but I would rather than have suggestion that because you are using the binary relation, so I would like to recommend you to use logistic regression also, because that will help you in this research.
Yeah, actually, logistic regression, it's a wrapper, approach, and but it is something the work is still ongoing. So definitely, thank you for your advice. It's something to be considered.
Thank you from my side.
Thank you.
It seems that we have only 2 people asking. Like it's our job to do so. But anyway, nice job. But I just some comments and suggestion, right? So even though you claim that the synthetic data is good in different ways, but in the academic world, we do want to go for the practical world. For example, we need the real data. So it may be better if you can map your synthesis data to the actual data. Then you can basically try to, for example, because the actual data has the limited numbers, right? And if you can make a model to represent the actual data, and that will be very good, because in the research we can use your model to basically enlarge the data side, right? I think one of the good data set is the from UCI, right? You can take a look, right? There are tons of the data set that is based on for the machine learning researchers, right? And if you can develop like that, it will be very good and it can worth for the researcher, right? Again, just, I mean, good job. But again, if you can try to model the real world, I mean, data set, that'd be very good. And thank you.
Thank you. Thank you for your advice. And I must say that in this recent publication that we have, we looked at something, a notion called complexity of data set. And we have measured the complexity and we mapped the performance of the feature selection algorithm with the complexity of data to try to have a better understanding of the real data and why one feature selection work well for such data, for one data, but not in the other. So this is, again, it's we are working on that field as well with more real data. But thank you for your advice.
Thank you so much, ma'am, for your presentation. We'll be moving on to the next presentation. Next up, we have Elias to present his paper titled The Use of User-Centered Design Strategies to Design Wearable Mobile Health Technologies, a systematic literature review. Are you there, sir?
Yes, I'm here. Can you confirm if you can hear me?
Yes, sir, I can hear you. You may start with the presentation.
Thank you very much. Let me start by saying good afternoon to everybody, at least in South Africa, it's afternoon.
Good afternoon.
And okay, yeah, let's just start sharing. All right, I think you can see my screen now.
Yes, sir, we can see your screen now.
Okay.
Yes,
Thank you. Thank you very much for the opportunity to present the paper to you. So basically where we are with the where we are with the research. The research paper was an SLR, systematic literature review. Is the use of we were investigating user-centered design strategies to design wearable mobile health technologies. So this was basically just looking at how they are presented, how user design strategies are used in the design of wearable technologies with a specific focus on mobile health. So the structure of the presentation will be as follows. We'll give an overview followed by the methodology used in the SLR and then look at the UC strategies themselves and the findings of the literature review and then the discussion as well of the SLR and the conclusion obtained from the research study and the limitations that were observed from the research study. So moving on to the next slide. Thank you. So the SLR itself proposes the proposal of the SLR was a consolidated overview of the application of user-centered design in wearable technologies within the mobile health domain and how this UCD plays an integral role in ensuring their usability in terms of the requirements of the user and their functionality and adoption meaning retention by the user. As such, that SLR provides a useful referential source for designers and health practitioners, because what we found that was we had these UCD strategies, but they were not in any way categorized or related to each other. Each paper that we sort of looked at was using independently using strategies, but the strategies were not referenced or categorized in any way. So the study then proceeded to use a glossary compiled by Dob, Parisi, and Munson and Lyon of 2018, which listed 30 UCD strategies. And then from those strategies, we'll see later on where we also used, there was a categorization by Helbostad, which we'll cover in the next slide, which we used to categorize the UCD strategies. So in short, the objective of the SLR itself, of the systematic literature that we've conducted, was the purpose of this of the SLR was to review and determine how these UCD strategies are applied in the design of wearable technologies with specific emphasis within the mobile health. And if I can just pause here and apologize to my co-author who's in the audience as well, Professor Magdal Mathieu, who also co-authored the SLR. She's with me here today, and thanks for attending. Apologies for that. And then proceeding to the next slide. So the methodology as provided by or used in the SLR was that we used the systematic literature review, and the search conducted was between March 23 and July 23. The databases that were used, it was all electronic, and all of the databases that were used was ACM Digital Library, IEE, Explore, Digital Library, Medline, PubMed, ProQuest Central, Science Direct, Springer Link, and Taylor and Francis. So all the source articles were peer-reviewed articles, which we used all of them electronically as mentioned. So the selection process started with the identification of the initial data set consisted of 4,937 papers. And then screening resulted in only 136 papers remaining. And of those 136, only 106 were eligible papers based on given criteria that we were using. And of the 106, we were left with a total of 30 papers only, which were included in the study. Right, now to the crux of the research. So the UCD itself is defined, or user-centered design is defined as a collection of procedures, systems, and attitude or knowledge attempting to always involve and revolve wearable technology design and development around the actual user of the technology. So the user in UCD is always central to the design, unlike in traditional design methodologies where requirements are gathered and then designers disappear somewhere in a back room and they come back with a product to give to the user, and 9 out of 10 times the user would say, no, that's not what I requested. So with UCD, the user is always central in the design. So by conducting the literature review based on the strategies, UCD strategies of DOP, we identified the 30 UC strategies as mentioned. The intended goal is to provide a common language that can be shared between implementation experts and UCD experts. The strategies has been grouped according to the overarching iterative design phases of mobile health applications suggested by Helbostat. The three phases which mentioned are the three phases which were used to categorize the 30 UCT strategies are: 1, interactive requirements gathering; joint design and usability and functionality evaluation. So this one, the first one, the interactive requirements gathering is basically the gathering of user requirements in collaboration with the users, with the user being central to the whole process. And the joint design one refers to the wearable technology design with input from the users, and the users being an active participant throughout the whole process. And collaborative testing of the technology jointly by designers and users. So as can be seen from all the three phases, the user is always central, from the requirements gathering to the design, right up to the evaluation phase. And so the following table is just a summarization and a sample to show how the 30 UCD strategies were categorized based on the three categorizations of Helbostat. So basically what we have here is these are the UCD strategies from DOP et al. These three. So we only took 3 from the 30 per categorization. So this is just an example of how DOP identified a UCD strategy. For example, we can just look at 1 per categorization. Here it says identify key users and their requests. So the definition meaning highlight key issues formulated from the perceptions of users and affected by the need that the wearable technology would satisfy. So the authors of the SLR categorize this, in a subjective way to say this refers to the interactive requirements gathering. And that's how we sort of came up to the categorizations to say there's no scientific way, if I can also qualify that now at this stage, there's no scientific way to say what UC strategy belongs to which categorization. This was a purely a intuitive and a subjective exercise to categorize the UCD strategies. And this is just an example of how the data extraction from the 30 research articles that were used as input. So what we did was that we looked at at each of the 30 articles on the actions that they performed in that development of wearable technologies. And from those actions that they performed in that design process, we selected the actions that best suited each UCD strategy and categorize them accordingly, sorry. For example, in this one, it was to review study on this is the title of the article, to review study on the developmental of exoskeletons as a wearable technology for assistive living. So the action within the article itself was anticipation of users' needs and preferences based on assumptions and or literature using personas. And we categorize that as engaged prospective technology users to create user personas and usage scenarios. There's a missing categorization here, which is this one would be under design. The categorization would be design. So the second one would be wearable technologies to assist people living with dementia. The results are presented in terms of design, technical problems, target perception from the participant perspective. Suggestions for improvement were pointed out by the users. So the strategy there was perform knowledge assessment, perform session to understand user perception. Obviously, this was user requirement as well, gathering. And then the last one was wearable technology design that assist older people in social engagement. On the other hand, these stakeholders also include domain experts who had specialized in certain aspects of the target design challenge as the action within the research article. And that was assigned the delegate tasks. Yes, ma'am.
Yes, sir, but you have 2 minutes to conclude your presentation.
Okay, thanks a lot, ma'am. So if you can move on to the next slide. The findings from the literature itself was that after the categorization, what we found that was that per categorization, these were the three most highly UCD strategies. Under interactive requirements gathering, we'll just look at one. It was to engage prospective technology users. Under joint design, it was to perform joint creation design sections. And under the usability and functionality evaluation, it was for workshops of user assessment. Those are the research articles. So in terms of what it means is that 29 research articles use UCD strategy. So the rest goes for all of them. And then if we move on, so top 3 of the 18 health conditions included in the research article. So most studies focused on wearable technologies for the management of mental health. 22% of those articles. Number 2 is care for the older people, which is 20% of the research articles. And stroke victims, 9% of the 30 research articles were mentioning stroke or the wearable technologies regarding to stroke victims. And then number 3, this is the wearable technologies. Top 3 wearable technologies. Smartwatches accounted for 20%. And then activity trackers accounted for 13% of the total articles. Smart bands accounted for 9% of the wearable technologies within the 30 research articles. Below are high-level focus areas of the research study pertaining to the UC strategies per design phase. So in terms of the interactive, I think we'll just look at one per categorization or phase. So in terms of interactive requirements gathering of user requirement is critical stage as the user requirements capture the expectations of the user concerning relief sought from the wearable technology while providing input to the functional specification of the design, which is true because if you get this stage wrong, then all your subsequent stages will be wrong. So it's very crucial that the very first stage, you ensure that your requirements are correct. On the joint design phase, the joint technology design is a methodology that requires that users and designers are all active participants in the design process according to the user requirements. I think the key term there is active between designers and users, that they are all active and that the users are not just a passive participant who give requirements and then disappear. Under the usability functionality evaluation, the article used in this phase represented various UC activities crucial in validating wearable technology usability and functionality against the requirements and the design specification as finalized by the key stakeholders. The key stakeholders as well were part of the design process, and they were all taken along from the requirements gathering stage, and right after the usability, they also give in their input to say they are happy with the design. So the limitations that were experienced from the study, the 30 UC strategies used, some can be consolidated, which is also a consideration for future studies. Given time, other researchers can choose to consolidate 30 and not use all 30 of them. The classification as well, as I mentioned, that this was purely intuitive and subjective exercise to say which UCD strategy belong to which categorization. Other researchers might see it differently and see something as not a user requirement, but see it as a design process and so on. So more research is also required on the relationship between UC strategy, health condition, and wearable technology type needed, because this is also interlinked as well. And it would be interesting to see what other researchers can come up with in that regard. In conclusion, the SLR review provides a consolidated view of the use of the 30 UCD strategies in the design of wearable technologies for mobile health. The 3 design phases were discussed as well, which are interactive requirements gathering, joint design, and usability and functionality evaluation of the design of wearable health technologies. It was found that the most UCD strategies are to engage users, perform joint creation and design sessions, and evaluate usability through usability assessments, and conducting workshops with different stakeholders for user assessment analysis. These are the most popular ones. It is also clear that the age of the wearer, of the user of the wearable technology, and their digital literacy and the restrictions caused by the illness or health condition influence the choice of UCD strategies. This is also another area for future research as well. It can also, it also belongs in the future research. It can provide good input there. So with that, I'd like to thank you for the opportunity and open the floors for any questions and answers.
Thank you so much, sir, for your presentation. Sir, do you have any questions?
No question from my side. Thank you.
No question from me.
Okay, sir. Thank you so much for your presentation, sir.
Thanks a lot. Thanks. Pleasure. Bye-bye.
Yeah. Thank you so much, sir, for your presentation. So I would like to sincerely thank our authors for their excellent presentations and the contribution in this session, and all the participants for being the part of this international conference. I hope this session was informative enough for each one you. We, on the behalf of whole team, thank you for your support during the 9th version of this conference and all the previous 8 versions. We will be happy to have you in the 10th version in 2025 as well. All the presenters would be getting their digital certificates through the email within the 2 working days. Further, all the papers have been already forwarded to the Springer. The publication will be live within 6 months. So kindly cooperate with the team of ICIT. I would also like to thank our session chair for chairing this session, Professor Kalpesh M. Popat. Sir, would you like to share any closing remarks?
First of all, I'm very much thankful to the organizing committee for inviting me as chairperson of this technical session. I want to express my heartfelt thanks to all participants. Your contribution is truly invaluable, and the discussions are truly enlightening. I also want to encourage all of you to carry the same spirit of inquiry and collaboration forward as you work in your field. Thank you very much.
Thank you so much, sir. This is a token of love and appreciation from the whole team of ICICT 2024.
Thank you
Also,
very much.
I'd like to thank our session chair, Dr. Chakshay Soin, for chairing this session. So this is the token of appreciation on the behalf of the whole team of ICIT 2024 and the Global Knowledge Research Foundation. So would you like to share a closing remark with us?
Okay. First of all, I thank you, audience and committees and the conference, basically. And this is good. Conference, it has been for years, and the paper is, keep, increasing, and there are many variety of the researchers, are coming in, right? And hope that we will have more paper in the next year. And for the audience, I think we already discussed and have some good comments. And if you could, enhance or improve your works, and maybe next year we'll see again. And thank you again. Dr. Jane, thank you.
Thank you so much, sir. So I would like everyone to open their camera for a quick snapshot. Thank you so much, everyone, for your valuable presence. We highly appreciate your presence. Thank you so much. Thank you so much.
You.
Thank you.
Thanks a lot.
Thank you. Bye-bye.
Thank you so much, sir.
Thank you.
Thank you. Thank you so much, sir. Thank you. Thank you.